Where does our consciousness go when we're sleeping? Every night you perform an act of evolutionary suicide. You close your eyes, paralyze your muscles, and surrender all awareness of a dangerous universe for 8 hours. If sleep wasn't the most critical function of your biology, nature would have bred it out of our DNA millions of years ago. Instead, it is the one thing we cannot live without. Tonight we ask the question science is only just beginning to answer. Where does your consciousness go when you are sleeping? Imagine a life where the observer, that I am at the center of your mind, refuses to leave. There is a terrifying condition called fatal familial insomnia. It is a glitch in the hardware of the soul where the gates of sleep are welded shut. Patients don't just feel tired, they begin to dissolve. Their memories turn to hallucinations. Their body temperature fluctuates wildly. Their nervous system enters a state of permanent, agonizing on. Without the nightly transformation of consciousness, the human system literally burns out. This tells us something profound. Sleep isn't just rest. It is a high-stakes physics operation, a maintenance cycle that keeps your reality from collapsing. Welcome to Sleep Entangled, where we bridge the gap between ancient wisdom and the quantum frontier. I'm your guide through the contemplative darkness. If you find peace in these nocturnal explorations, remember to subscribe. It helps the algorithm find others who are seeking these same answers. Tonight we aren't just talking about why you're tired. We're exploring the glymphatic flush, the quantum rhythms of your neurons and the secret language of the Shen. Settle deeply, breathe slowly, let the weight of the day dissolve. We are entering the science of the unseen. Chapter 1. The Sleep Paradox. You will spend approximately 1/3 of your life asleep. If you live to 80 years, 27 of those years will be unconscious, unaware, your body motionless, your mind wandering through landscapes that dissolve upon waking. This is not optional. This is not leisure. Sleep is as fundamental to survival as oxygen, as water, as food. Deprive yourself of sleep for long enough and you will die, not from starvation, not from dehydration, but from the simple, mysterious absence of sleep itself. There exists a rare genetic disorder called fatal familial insomnia. It is exactly what it sounds like, insomnia that kills. Patients lose the ability to sleep. At first, the symptoms are subtle: difficulty falling asleep, fragmented rest, increasing exhaustion. But as weeks pass without true sleep, the brain begins to fail catastrophically. Hallucinations emerge, memory collapses, motor control deteriorates, and within months, sometimes a year at most, the patient dies. Not because they are tired, not because their body has given out from exhaustion. They die because their brain, deprived of sleep, can no longer sustain consciousness itself. This tells us something profound. Sleep is not rest in the passive sense, not simply the absence of waking activity. Sleep is an active, essential process that the brain must perform to continue functioning. Every animal with a brain sleeps in some form. Dolphins sleep with half their brain at a time, one hemisphere resting while the other maintains swimming and breathing. Birds can sleep mid-flight, portions of their brain shutting down while others navigate. Even insects, creatures with nervous systems so simple we hesitate to call them conscious, exhibit sleep-like states where they become less responsive, more vulnerable to predators, as if surrendering to some biological imperative stronger than survival itself. And this is the paradox. Sleep makes you vulnerable. A sleeping animal cannot hunt, cannot flee, cannot reproduce, cannot defend territory. From an evolutionary perspective, sleep should have been eliminated long ago. Any mutation that allowed an organism to skip sleep would grant enormous advantages: more time to eat, to mate, to avoid being eaten. And yet sleep persists across every branch of the animal kingdom, conserved with the same evolutionary insistence as DNA replication or cellular respiration. Natural selection has not removed sleep, it has protected it fiercely. Why? What happens during sleep that is so essential, so irreplaceable, that nature would rather make you unconscious and defenseless than allow you to skip it? Satsapte. For most of human history, we had no answer. Sleep was mysterious, sacred, frightening. Ancient cultures saw sleep as a kind of death, a temporary departure of the soul from the body. Aristotle thought sleep was a cooling of the heart. The Chinese sages called it the withdrawal of the Shen. They were both wrong about the mechanics, but they were right about the feeling. Something is being reset at a level deeper than chemistry. All of them were grasping toward the same truth. Something profound happens when we sleep, something that cannot happen while we are awake. Consciousness itself must change state, must transform, must enter a different mode of being for the brain to continue functioning. It was not until the 20th century that we began to glimpse what that transformation might be. In 1924, German psychiatrist Hans Berger invented the electroencephalogram, the EEG, and discovered that the sleeping brain does not go quiet. It generates waves, rhythms, patterns of electrical activity that shift through the night in predictable cycles. The brain during sleep is not turned off. It is doing something, working, processing, transforming. And then, in 1953, Eugene Oserinsky and Nathaniel Kleitman at the University of Chicago discovered REM sleep, rapid eye movement sleep, a state in which the brain becomes nearly as active as during waking, the eyes moving frantically beneath closed lids, the body paralyzed to prevent dreamers from acting out their visions. We dream, they realized, in coordinated stages. Sleep is structured, organized, purposeful. But still the central question remained unanswered. Why must consciousness dissolve each night? What work is the sleeping brain performing that the waking brain cannot? In 2012, a researcher named Micah Nedergaard at the University of Rochester made a discovery that would fundamentally change our understanding of sleep. She found something no one had seen before, hidden in the spaces between brain cells, operating only in the dark hours when consciousness fades. She discovered the brain's waste removal system, a network that functions almost exclusively during sleep, flushing toxins, clearing metabolic debris, washing the brain clean. Sleep, it turns out, is when your brain takes out the trash. And that discovery, simple as it sounds, opened a door into one of the deepest mysteries of consciousness itself. Because if the brain must shut down awareness to clean itself, what does that tell us about the relationship between consciousness and the physical brain? What does it mean that thinking itself produces waste that can only be cleared in the absence of thought? Let this question rest gently in your mind. Your brain, at this very moment, is awake, generating electrical signals, forming memories, sustaining the sense of you that is reading these words. And tonight, when you sleep, that same brain will transform. Consciousness will fade, awareness will dissolve, and something ancient, something essential, something we're only beginning to understand, will begin. Chapter 2. The Glymphatic Revolution. Your brain weighs about 3 pounds. It represents roughly 2% of your body weight, and yet, astonishingly, it consumes 20% of your energy. 20%. Your brain is the most metabolically expensive organ you possess, burning through glucose and oxygen at a rate that would bankrupt any other tissue. All that activity, all that thinking and sensing and remembering produces waste. Metabolic byproducts, damaged proteins, cellular debris, the molecular garbage that accumulates whenever cells work hard. Every other organ in your body has a straightforward waste removal system. Your muscles, your liver, your kidneys, they all use the lymphatic system, a network of vessels that carries away metabolic trash and delivers it to the bloodstream for disposal. Simple, efficient, elegant. But your brain has no lymphatic system. None. For over a century, this baffled neuroscientists. How does the brain take out the trash? Where does all that metabolic waste go? The brain is sealed behind the blood-brain barrier, a selective filter that keeps most substances in the blood from entering brain tissue. Wonderful for protection, keeps toxins and pathogens out, but terrible for waste removal. The brain seemed to be creating garbage with no way to dispose of it. And then, in 2012, Micah Nedergaard and her team at the University of Rochester discovered something extraordinary. They were studying the brains of living mice using 2-photon microscopy, a technique that lets you watch individual cells functioning in real time. They injected fluorescent dye into the cerebrospinal fluid, the clear liquid that bathes the brain and spinal cord, and watched what happened. What they saw shocked them. The dye didn't just sit there, it moved. It flowed through the brain in waves, travelling along the outside of blood vessels, diving deep into brain tissue, flushing through the spaces between cells like a river cleaning a canyon. The cerebrospinal fluid was circulating through the brain, carrying waste away, draining into the lymphatic vessels in the neck. The brain did have a waste removal system. It had just been invisible until that moment. Nedergaard called it the Glymphatic System, a combination of glia, the support cells that line the fluid channels, and lymphatic, the system it resembled. And here's where it gets interesting. This glymphatic system barely functions when you're awake. The channels are too narrow, the flow too sluggish. But when you fall asleep, something remarkable happens. The brain cells actually shrink by about 60%, opening up the spaces between them like streets widening after cars pull into driveways. Cerebrospinal fluid floods in, washing through the brain at 10 to 20 times the waking rate, flushing away the accumulated debris of the day. Your brain literally cleans itself while you sleep. The glymphatic system is most active during deep sleep, specifically during slow-wave sleep, those deep NREM stages when your brain waves slow to long rolling rhythms. This is when the cleaning happens. This is when beta amyloid, the toxic protein that accumulates in Alzheimer's disease, gets washed away. This is when metabolic waste, the molecular exhaust from a day of thinking, gets cleared out. Think about that for a moment. Every thought you have, every memory you form, every decision you make produces waste, and that waste can only be cleared efficiently while you sleep. Staying awake doesn't just make you tired, it lets neurotoxins accumulate. Studies have shown that a single night of sleep deprivation causes beta amyloid levels to rise measurably in the brain. One night. Not sleeping doesn't just make you foggy the next day, it literally leaves your brain sitting in its own waste. This discovery helps explain so many mysteries. Why does sleep deprivation increase the risk of Alzheimer's and dementia? Because chronic sleep loss means chronic failure to clear beta amyloid, allowing it to build up year after year until plaques form and neurons die. Why do people who consistently sleep poorly age faster cognitively? Because their brains are never fully cleaned, metabolic damage accumulating like rust on machinery that's never maintained. It also explains something peculiar about sleep position. Nedergaard's team found that the glymphatic system works most efficiently when you sleep on your side. Not on your back, not on your stomach, on your side. The fluid channels align better, the drainage pathways open more fully. This might be why so many animals instinctively curl up on their sides to sleep, why humans across cultures tend to prefer side sleeping. Your body knows, at some deep biological level, how to position itself for optimal brain cleaning. The implications ripple outward. Alcohol, for instance, suppresses glymphatic function, even while making you feel sleepy. You pass out, but your brain doesn't clean itself properly. Anesthesia does something similar. You're unconscious but not truly sleeping, and the glymphatic system barely activates. This might explain why people often feel cognitively foggy after surgery, why recovery takes so long. The brain was shut down but not restored. And here's something that brings us closer to the quantum mystery of consciousness. The glymphatic system seems to require the brain to be in a specific state, not awake, not merely inactive, but actively sleeping. As if consciousness itself must withdraw for the cleaning to begin, the observer must step away. Awareness must dissolve. Only then can the brain perform this essential maintenance. Traditional Chinese medicine, remarkably, intuited something similar over 2,000 years ago. TCM physicians described sleep as the time when Shen, the spirit, the conscious awareness, returns to the heart organ to rest and restore. During waking hours, Shen moves outward through the senses, engaging with the world, consuming energy. At night, Shen withdraws inward, and the body's yin forces, cooling, moistening, restorative, take over. The organs perform their nighttime work. The liver cleanses the blood. The kidneys store essence. The heart houses the spirit in peaceful stillness. Modern neuroscience describes cerebrospinal fluid washing through extracellular channels, while neurons shrink and metabolic waste drains away. Ancient medicine described spirit withdrawing, while vital energy circulates through organ meridians, restoring balance and clearing stagnation. Different languages, different frameworks, describing perhaps the same profound truth. Your brain cannot maintain consciousness and clean itself simultaneously. Awareness itself seems to interfere with restoration. Think about that. The very act of being conscious, of observing, thinking, experiencing, prevents the brain from clearing the waste that consciousness creates. It's almost paradoxical. You must stop being aware to maintain the capacity for awareness. So every night, when you feel yourself growing drowsy, when your thoughts begin to drift and dissolve, when the world fades and sleep pulls you downward, this is not failure. This is not weakness. This is your brain preparing for essential work. The glymphatic channels are beginning to widen. Cerebrospinal fluid is beginning to flow. The cleaning is about to begin. And as you rest here, perhaps already feeling the gentle weight of sleep approaching, let yourself appreciate the elegance of it. Your brain knows what it needs. The moment you surrender consciousness, restoration begins. The waste of today will be washed away tonight, and tomorrow you will wake with a brain refreshed, cleared, ready once again to generate the electricity of thought, the chemistry of emotion, the quantum collapse of observation. Let that thought drift gently now as we move deeper into the mechanism of sleep itself, into the stages and rhythms, into the mystery of how consciousness fades and where it goes when it does. Chapter 3: Consciousness Fades, the Descent into Sleep. What does it feel like to fall asleep? Strange question, isn't it? Because by definition, you're never awake to experience the moment you fall asleep. You can feel yourself getting drowsy, feel your thoughts becoming loose and scattered, feel your body growing heavy. And then, Nothing. A gap. You vanish, and hours later you reappear, waking to morning light with no memory of the transition. Sleep researchers have mapped this descent with extraordinary precision using EEG recordings, watching the electrical patterns of the brain shift as consciousness dissolves. And what they found is fascinating. Sleep is not an on-off switch. It's a gradual transformation, a slow fade through distinct stages, each with its own characteristic brain waves, its own depth of unconsciousness. When you're fully awake and alert, your brain produces beta waves, fast, irregular oscillations that reflect active thinking, sensory processing, the constant chatter of conscious awareness. As you relax, perhaps closing your eyes, beta waves give way to alpha waves, slower, more rhythmic, the brain's idling pattern. You're still conscious, still aware, but quieter now, less engaged. Then comes stage 1, the lightest phase of sleep lasting just a few minutes. Your alpha waves fade and theta waves emerge, slower still, around 4 to 7 cycles per second. Your muscles relax further. Your breathing slows. If someone were watching you, they might see your eyes begin to roll gently beneath closed lids. You're drifting now, thoughts fragmenting into brief, dreamlike flashes, hypnagogic imagery, those strange half-visions that make no sense but feel oddly compelling. A face appears, a voice speaks, a sensation of falling jolts you awake. Many people experience that falling sensation, the hypnic jerk it's called, a sudden muscle spasm that yanks you back from the edge of sleep. No one knows exactly why this happens. Some researchers think it's a glitch in the neural transition from waking motor control to sleep paralysis. Others suggest it's an evolutionary artifact, the brain's ancient panic response mistaking relaxation for literal falling from a tree branch. Whatever the cause, it's a reminder of how strange this transition is, how consciousness doesn't slip quietly away but sometimes fights, jerks, resists the pull into unconsciousness. If you don't wake, you sink deeper into stage 2. This is where you spend most of the night. About half your total sleep time lives here. Your brain waves slow further, dominated now by theta rhythms punctuated by sudden bursts called sleep spindles, brief explosions of activity lasting just a second or two. These spindles seem to be important for memory consolidation, the brain processing and storing the day's experiences. You're truly asleep now, disconnected from external reality, though still easily awakened. A door closing might bring you back, a whispered name might pull you up. But if you remain undisturbed, you descend into stage 3, slow wave sleep, deep sleep, the most restorative phase of all. Your brain waves stretch out into long rolling delta waves, powerful and slow, just 1 to 3 cycles per second. These are the rhythms of deep unconsciousness. Your blood pressure drops, your breathing becomes slow and regular, your muscles go completely slack. This is when growth hormone releases, when tissue repairs, when the glymphatic system reaches peak efficiency, cerebrospinal fluid flooding through your brain in cleansing waves. You're profoundly unconscious here. Studies show that people woken from deep sleep are disoriented, confused, sometimes unable to remember where they are or why someone is shaking them awake. Consciousness doesn't just turn back on, it staggers back slowly, reassembling itself piece by piece. And here is where it gets truly interesting from a physics perspective. During waking, your brain exists in what we might call a definite state. You're experiencing this moment, processing these words, maintaining a coherent sense of self in time and space. But as you descend through sleep stages, that coherence begins to blur. In stage 1, your thoughts fragment. In stage 2, external reality disconnects. In stage 3, the sense of you dissolves almost completely. There is no narrative continuity, no observer watching, no unified consciousness holding the world together. It's almost as if consciousness itself is a kind of measurement, a continuous observation that collapses possibility into experience, and when that observation stops, when you fall asleep, the brain enters something closer to a superposition, multiple states overlapping, quantum possibilities that will only collapse back into definite experience when you wake. This is not metaphor. The parallel runs deeper than you might think. In quantum mechanics, observation collapses wave functions into definite states. In consciousness, waking awareness seems to collapse the diffuse activity of the sleeping brain into coherent linear experience. The observer creates classical reality from quantum possibility, and when the observer sleeps, perhaps something similar happens, classical experience dissolving back into the quantum foam from which it emerges each morning. Traditional Chinese medicine describes this transition beautifully. As sleep approaches, they say, yang energy, active, outward, conscious energy, withdraws inward. Yin energy, passive, restorative, unconscious energy, rises to dominance. The Shen, the spirit, releases its grip on the external world and turns inward toward the heart, toward stillness, toward the formless void from which consciousness arises and to which it must return each night, whether you describe it in brain waves or energy conduits, in neural oscillations or spirit returning home. The truth remains the same. Every night you let go, you surrender, you fall backward into darkness, trusting, because you must trust, because you have no choice, that you will return. And in that surrender, in that nightly death and rebirth of awareness, something essential happens. Something that cannot happen while you remain awake. The brain shifts states. Consciousness transforms, and in the next stage of sleep, in the realm of rapid eye movements and impossible visions, the quantum strangeness of the mind reveals itself most clearly. Dreams are waiting. Let us drift toward them now, as the brain descends deeper still into the mystery of REM sleep, where physics and impossibility dance together in the theatre of the sleeping mind. Chapter 4. Dreams and Quantum Superposition. Approximately 90 minutes after you fall asleep, something extraordinary happens. Your brain waves, which have been rolling in slow delta rhythms during deep sleep, suddenly accelerate. They become fast, chaotic, almost indistinguishable from waking patterns. Your eyes begin to move rapidly beneath your closed lids, left, right, up, down, as if watching some invisible scene unfold. Your heart rate increases, your breathing becomes irregular, and yet your major muscle groups become completely paralyzed, locked by a signal from your brainstem that prevents movement. You are dreaming. REM sleep, rapid eye movement sleep, is the strangest state your brain enters. In some ways, you are more active during REM than during waking. The visual cortex blazes with activity. The emotional centers of the brain light up intensely. The hippocampus, which stores memories, replays and reorganizes the day's experiences, and yet you are profoundly unconscious, disconnected from reality, experiencing a world that does not exist anywhere except inside your skull. Dreams defy the rules that govern waking life. In dreams you can fly, you can breathe underwater, you can be in two places simultaneously, or be two people at once. Time dilates and contracts, minutes feel like hours, or entire years compress into moments. Causality breaks down. You're in your childhood home, and then suddenly you are at work, and somehow this transition requires no explanation, feels perfectly natural. The laws of physics do not apply. Logic does not apply. And yet, while you are dreaming, none of this seems strange. The impossible feels normal. Why? What is happening in the brain that requires, this suspension of physical law and logical consistency? One way to think about dreams is as a kind of quantum superposition of possibilities. During waking consciousness, your brain takes the vast ambiguity of sensory input and collapses it into a single, coherent narrative. This is where you are. This is what you are doing. This is who you are. Observation, consciousness itself, selects one possibility from many and makes it real. But during REM sleep, that collapse does not happen. The brain generates scenarios, memories, emotions, images, but there is no observer forcing them into coherence. They exist simultaneously, overlapping, contradictory, uncollapsed. You are you, and also your friend, and also a stranger. You are here, and also there. The past and future blend. Multiple storylines coexist. It is only when you wake, when the observer returns, that the dream collapses into memory, a single linear narrative extracted from what was, during the dream itself, a fluid superposition of many possible narratives. In quantum mechanics, the famous thought experiment of Schrödinger's, a cat is in a box, simultaneously alive and dead until someone opens the box and observes it, forcing reality to choose. Dreams are like that unopened box. While you dream, all possibilities exist at once. The dreaming mind occupies a superposition of states, and when you wake, the observation collapses the dream into one remembered story. Though you often sense that there were other dreams, other storylines, happening simultaneously that you can no longer quite reach. This is why dreams are so hard to remember. Memory requires coherence, a stable narrative that can be encoded and recalled. But dreams are not coherent. They shift, dissolve, contradict themselves moment by moment. You wake with fragments, a face, an emotion, a strange image, but the connective tissue is gone, evaporated the moment consciousness returned and tried to impose order on quantum chaos. Lucid dreamers, people who become aware they're dreaming while still asleep, report something fascinating. The moment they realize they're dreaming, the dream often becomes unstable. Their awareness, their observation, begins to collapse the superposition. The dream tries to maintain multiple contradictory states, but the lucid observer is forcing it toward classical coherence, and the system cannot sustain both. Either the dreamer wakes up, or they lose lucidity and sink back into the uncollapsed dream state. Neuroscience describes this in different terms. The prefrontal cortex, the part of the brain responsible for logic, planning, self-awareness, is largely offline during REM sleep. This is why dreams lack logical consistency. The brain regions that would normally say, "Wait, this doesn't make sense," are quiet. Meanwhile, the emotional centers, the amygdala, the limbic system, are hyperactive. Dreams are emotionally vivid but logically incoherent because the architecture of consciousness has shifted. The editor is asleep. The emotions run free. But here is what fascinates me. Why does the brain do this? Why spend hours every night generating impossible worlds, experiencing scenarios that never happened and never could happen? Dreams consume enormous energy. They serve some function important enough that evolution has preserved them across species. Cats dream. Dogs dream. Even rats dream, their hippocampi replaying the mazes they ran during the day, learning and consolidating spatial memories while asleep. One theory suggests that dreams are threat simulations, the brain practicing responses to danger in a safe environment. You dream of being chased, of falling, of failing important tasks, and your brain rehearses emotional and physical responses without real consequences. Another theory proposes that dreams are emotional regulation, processing the feelings of the day, integrating difficult experiences, maintaining psychological balance. But there is a deeper possibility. What if dreams are the mind exploring the space of possibility itself? During waking, you are constrained by physics, by causality, by the linear flow of time. You can only be one person in one place doing one thing. But the quantum substrate of consciousness, if such a thing exists, is not limited this way. During sleep, perhaps the brain samples alternate configurations, explores branching timelines, accesses information that classical waking consciousness cannot reach. Some dreamers report precognitive dreams, visions of events that later happen. Most scientists dismiss these as coincidence, pattern matching, memory distortion. But quantum physics allows for retrocausality under certain interpretations, future events influencing past states. If consciousness has any quantum character, if observation genuinely participates in collapsing wave functions, then perhaps during the uncollapsed state of dreaming, the boundaries between past and future become permeable. I am not claiming this is proven, I'm saying the parallels are striking. Dreams exhibit quantum-like properties: superposition, entanglement of contradictory states, collapse upon observation, possible retrocausal elements. Whether this is metaphor or mechanism remains unknown. But it is curious, is it not, that the sleeping mind behaves so much like a quantum system? Traditional Chinese medicine offers yet another lens. Dreams, in TCM, are considered movements of the Shen, the spirit consciousness, unconstrained by the physical body. During sleep, the Hun, the ethereal soul, is said to wander, travelling through realms inaccessible to waking awareness. Dreams are journeys of the spirit, and while Western science might scoff, consider this. If consciousness is not produced by the brain but rather mediated by it, if awareness is a field or process the brain accesses rather than generates, then sleep might genuinely be a state where consciousness explores beyond the constraints of matter and time. You will spend approximately 2 hours each night in REM sleep, cycling through 4 or 5 dream periods, each longer than the last. 2 hours every night in quantum superposition, your mind sampling infinite possibilities, processing emotions, consolidating memories, exploring spaces that do not exist in classical reality. And every morning, you wake with only fragments, ghosts of those journeys, the rest dissolved back into the void. Perhaps dreams are the mind's way of staying quantum, of preventing consciousness from becoming too classical, too rigid, too locked into a single timeline. Perhaps we need to dissolve into impossibility each night to remain flexible, creative, capable of imagining futures that do not yet exist. Or perhaps dreams are simply the brain's screensaver, random neural noise given shape by a pattern-seeking mind. Either way, they are beautiful, strange, essential. And as you rest now, drifting through this exploration, perhaps you can feel it beginning. That looseness of thought, that fragmenting of narrative, that soft pull toward the impossible. The boundary between waking and dreaming is thinner than you think. Consciousness is always one slow breath away from dissolving into quantum wonder. Let us move now into what happens next, into the work the sleeping brain performs, into memory and consolidation, and the architecture of learning itself. Chapter 5. Memory consolidation during sleep. And here is something remarkable. If you learn a new skill during the day and then sleep that night, your brain will be measurably better at that skill when you wake, sometimes dramatically better, as if you practiced while unconscious. This is not metaphor. Sleep actively improves learning. The phrase "sleep on it" is not folk wisdom, it is neuroscience. In 2000, researchers at Harvard Medical School conducted a now famous experiment. They taught participants a visual pattern recognition task, spotting specific sequences in a field of images. The participants practiced until they reached a plateau. Then half of them slept and half stayed awake. When tested again, the group that slept improved significantly. The group that stayed awake did not. Sleep did something that waking rest could not. Further experiments refined the finding. It is not just time that matters, it is sleep specifically, and particular stages of sleep. Learning motor skills like playing a musical instrument or perfecting a tennis serve improves most during stage 2 sleep, where those sleep spindles we discussed earlier pulse through the brain. Learning declarative memories, facts, concepts, vocabulary improves during slow-wave sleep. And emotional memories, the kind weighted with feeling and significance, consolidate during REM. What is happening? Why does sleep transform memory? The answer involves a process called synaptic homeostasis. During waking hours, your brain is constantly forming new connections between neurons, synapses strengthening as you learn, weakening as you forget. But there is a problem. If synapses only ever strengthened, your brain would eventually become saturated, unable to form new connections because all the neural real estate would already be occupied. You need a way to prune, to reset, to weaken the unimportant connections so that important ones can stand out. Sleep does this. During deep sleep, your brain systematically weakens synapses across the board, a global downscaling that reduces neural noise and clears space for new learning. But not all synapses weaken equally. The important ones, the connections that represent meaningful experiences, repeated patterns, significant learning, resist this weakening. They are tagged somehow, marked as important, and they survive the pruning process relatively intact. Meanwhile, the trivial connections, the sensory noise, the irrelevant details fade away. The result is signal amplification. When you wake, your brain has essentially turned down the background noise while leaving the important signals loud and clear. Memories that matter stand out. Patterns become more obvious. Skills feel smoother, more automatic. This process involves something called memory replay. During sleep, especially during slow-wave sleep, your hippocampus, the brain region that encodes new memories, begins replaying the neural patterns of the day's experiences. If you spent the afternoon learning a new language, your hippocampus will fire in the same patterns it fired during the lesson, but faster, compressed, repeated hundreds of times. This replay transfers the memory from the hippocampus, where it is temporary and fragile, to the cortex, where it becomes stable and long-term. Think of it like this. The hippocampus is your brain's scratch pad, rapidly jotting down notes about everything you experience. But scratch pads fill up. You need to transfer those notes to permanent storage, the cortex, and you need to do it without losing the information. Sleep is when that transfer happens. The hippocampus plays back the day's recordings, and the cortex listens, slowly integrating the new information into its vast, interconnected web of long-term knowledge. REM sleep seems to handle a different kind of consolidation, emotional integration and creative connection making. During REM, the brain does not just replay memories, it remixes them, combining fragments from different experiences, finding unexpected associations, linking ideas that were never consciously connected. This is why solutions to problems sometimes appear spontaneously after a good night's sleep. Your sleeping brain was exploring the space of possibilities, trying combinations your waking mind would never consider. The chemist Auguste Kekulé famously discovered the ring structure of benzene after dreaming of a snake biting its own tail. The artist Salvador Dali would nap while holding a key above a metal plate, waking the instant he fell asleep and the key dropped, capturing the surreal imagery of hypnagogic hallucinations. Inventors, writers, scientists across history have reported breakthrough insights emerging from dreams, from the quantum-like exploration of possibility that happens when consciousness dissolves. And here is where traditional Chinese medicine intersects beautifully once again. TCM teaches that the heart houses the Shen during sleep, and the Shen integrates the experiences of the day, processing emotions, organizing thoughts, storing what is essential and releasing what is not. The practice of dream interpretation in Chinese medicine is not about predicting the future. It is about understanding which emotions, which memories, which unresolved experiences are being processed during the night. Poor sleep in TCM is often diagnosed as Shen disturbance, the spirit unable to settle, the heart restless, memories and emotions churning without resolution. The treatment involves calming the Shen, nourishing the heart, creating the conditions for peaceful integration. Modern sleep medicine would describe this as insomnia with rumination, the mind unable to transition from active processing to consolidation mode. Different language, same phenomenon. What both frameworks recognize is this: sleep is not passive. It is not merely rest. Sleep is active transformation of experience into wisdom, of exposure into expertise, of scattered information into integrated understanding. You do not simply store memories during sleep. You reorganize them, recontextualize them, discover meanings that were not apparent when the experiences first occurred. This is why pulling an all-nighter before an exam is catastrophically bad strategy. You might cram information into your hippocampus, but without sleep to consolidate it, the memories will be fragile, poorly integrated, likely to dissolve under stress. Sleep is not luxury. It is the completion of the learning process itself, and as you rest now, perhaps already feeling the mind's natural drift toward consolidation, toward integration, know that this very moment, this exploration of sleep itself, is being woven into your neural architecture. Tonight when you sleep, your brain will replay these ideas, strengthen the synapses that found them meaningful, prune away the details that do not serve. You will wake tomorrow understanding sleep more deeply than you do right now, not because you will review these words, but because your sleeping brain will integrate them, transform them, make them part of the structure of your knowing. Let us pause here briefly for a gentle acknowledgement of where we are. If you're still with me in this late-night exploration of consciousness and rest, you are part of something rare. Curious minds willing to drift through the science of sleep itself. A quick subscribe helps others find this journey into the mysteries of the sleeping brain. Now let us continue deeper, where ancient wisdom and modern neuroscience reveal the same profound truths about restoration and the return of the spirit. Chapter 6. The Shen returns. Ancient wisdom meets neuroscience. Over 2,000 years ago, Chinese physicians developed an intricate understanding of sleep without EEG machines, without MRI scanners, without any of the technological tools we consider essential to modern neuroscience. They observed, they listened to the body's rhythms, they traced the flow of energy through organs and meridians, and what they discovered, through centuries of careful empirical attention, maps onto modern sleep science with startling precision. In TCM, sleep is understood as the return of the Shen. The Shen is spirit, consciousness, the animating awareness that makes you distinctly you. During waking hours, the Shen moves outward through the sense organs, eyes seeing, ears hearing, mind thinking, the spirit engaging actively with the world. This outward movement consumes yang energy, active, warm, dynamic energy. You spend yang all day long in the act of being conscious, but yang cannot burn forever without replenishment. As evening approaches, yang energy naturally declines and yin energy rises. Yin is cool, restorative, quiet, internal. As yin ascends, the Shen withdraws from the senses and returns to its home, the heart organ. In TCM, the heart is not merely a pump, it is the residence of consciousness itself. When Shen rests peacefully in the heart during sleep, the body can perform its restorative work. When Shen fails to settle, sleep becomes disturbed, restless, insufficient. Modern neuroscience would describe the same transition differently. As evening arrives, the suprachiasmatic nucleus in the hypothalamus responds to decreasing light and begins signaling the pineal gland to release melatonin. Melatonin does not cause sleep directly, but it initiates the cascade of changes that make sleep possible. Body temperature drops, alertness fades, the brain's arousal centers quiet. Adenosine, a metabolic byproduct that accumulates during waking hours, builds up in the brain and promotes sleepiness by binding to receptors that suppress wakefulness. Yang declining, yin rising. Arousal centers quieting, sleep centers activating. The language differs, but the observation is identical. Consciousness withdraws as night falls, and the body enters a restorative state governed by different principles than waking. Chinese medicine goes further. It maps sleep to a circadian organ clock, where different organs are believed to perform their most active work during specific 2-hour windows through the night. Between 11 p.m. and 1 a.m., the gallbladder is active, making energetic decisions, sorting what to keep and what to release. From 1 a.m. to 3 a.m., the liver takes over, detoxifying blood, processing emotions, storing and releasing glucose as needed. From 3 a.m. to 5 a.m., the lungs dominate, governing respiration and the exchange of qi. This might sound mystical to Western ears, but consider what we now know. Liver function does intensify during early morning hours. This is when the liver performs its most active detoxification, metabolizing toxins accumulated during the day. Growth hormone releases in pulses during deep sleep, particularly in the first half of the night. Cortisol begins rising around 3 to 4 a.m., preparing the body for waking. These are not arbitrary. They are coordinated, rhythmic processes that match the traditional organ clock descriptions with surprising fidelity. The concept of Shen disturbance maps precisely onto modern sleep disorders. When patients present with insomnia in TCM clinics, the physician assesses which organ system is failing to support the Shen's return. If the patient cannot fall asleep, lying awake with racing thoughts, the heart yin may be deficient. There's not enough cooling, calming energy to draw the Shen inward. Treatment involves nourishing heart yin, using herbs like raw Rehmannia and Ziziphus seed, known for centuries to calm the spirit and promote sleep. If the patient falls asleep easily, but wakes at 2 to 3 a.m. and cannot return to sleep, TCM might diagnose liver blood deficiency or liver qi stagnation, the liver unable to store the blood properly, the spirit wandering restlessly. The treatment nourishes liver blood, smooths qi flow, addresses the emotional frustrations that disrupt rest. Herbs like white peony and angelica root support the liver's function. Acupuncture points along the liver meridian calm overactivity. Western sleep medicine would diagnose the same pattern as sleep maintenance insomnia, often associated with stress, anxiety, or early-stage mood disorders. The treatment might include cognitive behavioral therapy for insomnia, sleep hygiene education, possibly medication. Different interventions, but both systems recognize the same underlying pattern. The mind cannot stay at rest. Consciousness keeps reasserting itself when it should remain dissolved. And here is where it becomes profound. Both systems, ancient energetic medicine and modern neuroscience, recognize that sleep is not simply the absence of waking. It is an active state requiring specific physiological conditions. The brain must be in the right state. The organs must perform their coordinated functions. The spirit, or consciousness, depending on your language, must genuinely withdraw. The TCM understanding of sleep emphasizes balance. You need enough yin to counterbalance yang. You need blood to anchor the shen. You need qi to flow smoothly without stagnation. If any element becomes deficient or excessive, sleep suffers. This is holistic medicine. Sleep is not isolated from diet, from emotion, from lifestyle, from the season, from the quality of relationships. Everything interconnects. Modern sleep medicine increasingly recognizes the same holism, though it arrived from a different direction. Sleep does not exist in isolation. Chronic stress disrupts the hypothalamic pituitary adrenal axis, keeping cortisol elevated when it should drop, preventing deep sleep. Poor diet affects blood sugar regulation, causing nighttime awakenings. Lack of physical movement means adenosine does not accumulate sufficiently to promote sleepiness. Relationship conflicts activate the amygdala, generating anxiety that prevents the descent into rest. Everything interconnects. One of the most beautiful TCM interventions for sleep involves preparing the body for the shen's return. This is not a pill to knock you unconscious. It is a practice of transition, of honoring the shift from yang to yin, from activity to rest. In the evening, dim the lights. Excessive brightness tells the brain it is still daytime, suppressing melatonin. Eat lightly. A heavy meal diverts energy to digestion when it should be moving inward toward restoration. Avoid intense mental stimulation. Scrolling social media, watching exciting shows, engaging in arguments keeps the shen agitated and external. Instead, TCM recommends gentle activities that help shen settle. Warm baths. The heat draws energy and blood to the surface. Then as the body cools afterward, the inward movement towards sleep begins. Herbal teas, chamomile, passionflower, valerian, traditionally used to calm the spirit. Gentle stretching or qigong. Slow movements that release physical tension and smooth qi flow. Journaling or reflection, externalizing the day's thoughts so they do not churn endlessly in the mind. Modern sleep hygiene echoes all of this. Dim lights in the evening to support melatonin release. Avoid large meals close to bedtime. Reduce screen time. The blue light suppresses melatonin, and the content keeps the mind activated. Take a warm bath or shower. The temperature drop afterwards signals the brain that sleep is approaching. Practice relaxation techniques. Progressive muscle relaxation, deep breathing, meditation. Write down worries or tomorrow's tasks so the mind can release them. Two systems, 2,000 years apart, describing the same process of preparing consciousness to dissolve, of creating conditions for the spirit to return home, of honoring the transition from the noise of waking to the silence of sleep, and perhaps most profoundly, both recognize that you cannot force sleep. You can only create the conditions and then surrender. The shen returns when it feels safe to return, when the heart is calm, when yin energy supports the descent. Consciousness dissolves when the brain enters the right neurochemical state, when adenosine outweighs wakefulness signals, when the arousal centers finally quiet. Sleep requires trust. trust that the world will still be there when you wake. Trust that your body knows what to do. Trust that letting go of control is not dangerous but necessary, not weakness but wisdom. As you rest here, perhaps already feeling that familiar heaviness, that loosening of thought, that gentle pull toward unconsciousness, you're experiencing what humans have experienced for millennia. The Shen preparing to return, Yang giving way to Yin, consciousness beginning its nightly journey inward, toward the heart, toward restoration, toward the quiet place where healing happens. Let that process unfold naturally now, as we move toward the mystery of REM, toward dreams and observation, toward the quantum strangeness that waits in the depths of sleep. Chapter 7. REM Sleep and the Observer. There is a peculiar paradox at the heart of REM sleep. Your brain is almost as active as during waking, more active even in certain regions. The visual cortex blazes, the emotional centers pulse with intensity. And yet you are profoundly unconscious, experiencing a world that exists nowhere except in the firing patterns of your neurons. The dreaming brain creates a complete reality, sights, sounds, sensations, narratives, with no external input whatsoever. This raises a fascinating question from the perspective of quantum mechanics and consciousness. What happens to the observer during REM sleep? In quantum physics, observation is not passive. The act of measurement of observation fundamentally affects what is being observed. Before observation, quantum systems exist in superposition, multiple states simultaneously. A particle can be here and there, spinning up and down, wave and particle all at once. But the moment you observe it, the wave function collapses, the system chooses, it becomes definite, classical, real in the way we understand reality. Some interpretations of quantum mechanics suggest that consciousness itself plays a role in this collapse. Not consciousness as mere awareness, but consciousness as observer, the thing that transforms possibility into actuality, that brings the universe into focus. This is controversial, debated, far from settled science, but the parallel to sleep is striking nonetheless. During waking consciousness, you are constantly observing. You look at the world, and in looking, you collapse the quantum fuzziness of light waves into definite photons striking your retina, into neural signals, into the experience of seeing a tree. You are the observer, and your observation creates classical reality from quantum possibility. The universe, in a sense, becomes real through your attention. But during REM sleep, something strange happens. You're still experiencing a reality, a dream reality, but there is no external world to observe. Your eyes are moving beneath your lids, but they are not seeing. Your visual cortex is generating images, but they come from memory, from imagination, from recombination of stored patterns. You're observing an internal world entirely constructed by your brain. And here is the key. You're not aware that you are the one constructing it. The dream feels external, real, happening to you rather than being created by you. The observer has split. There is the dreaming self, experiencing the dream, and there is the brain, generating the dream. But the two are not connected by conscious awareness of their relationship. This is profoundly different from waking observation. When you look at a tree, you know you are looking. You know there is a separation between you, the observer, and the tree, the observed. But in a dream, that separation collapses. You're simultaneously the observer and the thing generating what is observed, but you do not recognize this. The measurement and the measured has become entangled. Lucid dreamers describe a fascinating threshold experience. The moment they realize they are dreaming, the moment awareness returns, and they recognize, I am observing a dream that I am creating, the dream becomes unstable. Sometimes it intensifies, becomes more vivid, more controllable. Other times it dissolves entirely and the dream awakes. The reintroduction of conscious observation changes the system. This mirrors what happens in quantum mechanics when you try to observe the process of measurement itself. The observer effect prevents you from watching a quantum system collapse without disturbing it. The act of observing observation changes what you are observing. Consciousness trying to watch itself dream changes the dream. REM sleep in this sense might be the closest we come to experiencing quantum-like reality, a state where observation and observed are entangled, where classical certainty breaks down, where multiple contradictory narratives exist simultaneously until waking consciousness returns and collapses them into a single remembered story. And here is what makes it even stranger. Your body knows you are dreaming. During REM sleep, your brainstem sends a signal that paralyzes your major muscle groups, a protective mechanism called rematonia that prevents you from acting out your dreams. Your brain is generating experiences of running, fighting, flying, but your body refuses to move. The system knows the dream is not real, even though your conscious mind does not. This dissociation is essential. When rematonia fails, a condition called REM sleep behavior disorder, people physically act out their dreams, often violently, sometimes injuring themselves or their partners. They punch dream attackers, run from dream threats, all while remaining unconscious. The separation between internal experience and external action has broken down. The dream has leaked into physical reality. Most of us experience this boundary as absolute. We dream wildly, impossibly, but we wake in the same bed where we fell asleep, uninjured, the world unchanged. The dream was entirely internal, and yet during the dream itself it felt completely real. More than real sometimes, hyper-real, emotionally charged in ways waking life rarely achieves. Traditional Chinese medicine describes dreams as the wandering of the hun, the ethereal soul, the aspect of consciousness that survives death and returns in the next life. During sleep, the hun travels through realms inaccessible to waking awareness, gathering information, processing unresolved emotions, exploring possibilities. Dreams, in this view, are not random neural noise. They are journeys of consciousness into non-physical dimensions. Modern neuroscience would say the hun is simply the default mode network, the brain's resting state network that activates when you're not focused on external tasks. During REM, this network runs wild, generating narratives, simulating social interactions, replaying and recombining memories without the constraints of external reality or executive control. Different frameworks, different languages, both describing the same phenomenon, consciousness detached from sensory input, exploring internal spaces, operating by rules that do not apply during waking, and both recognize something essential. REM sleep is not optional. Deprive someone of REM specifically, waking them every time they enter this stage, and they will suffer cognitive decline, emotional instability, eventually hallucinations even while awake. The brain needs to dream. Consciousness needs to explore its internal quantum spaces, needs to exist in superposition, needs to dissolve the rigid structures of waking observation and become fluid, contradictory, impossible. Perhaps this is the deepest purpose of REM sleep. Not memory consolidation, not threat simulation, not emotional regulation, though it does all these things. Perhaps REM sleep is how consciousness stays flexible, how the observer prevents itself from becoming too fixed, too certain, too locked into a single interpretation of reality. Every night for 2 hours you dissolve into quantum possibility. You observe without knowing you are observing. You create without recognizing you are creating. You experience realities that never were and never could be, and yet they feel more vivid, more emotionally true than most of your waking life. And then you wake. The observer returns. The wave function collapses. The dream dissolves into fragments, and you reassemble yourself, coherent, classical, definite, ready to face another day of collapsing quantum possibilities into the singular experience of being you. But the dream remains, encoded somewhere in neural patterns you cannot quite access, a reminder that consciousness is stranger and more fluid than the waking mind ever suspects. As we move now toward what happens when this delicate system fails, towards sleep disorders as disruptions of consciousness itself, let that strangeness rest gently in your awareness. Chapter 8. When Sleep Fails. Disorders as Consciousness Disruptions. When sleep works properly, you barely notice it. You grow drowsy, you lie down. Consciousness fades, hours pass, you wake refreshed. The cycle repeats night after night, automatic as breathing, essential as heartbeat. But for millions of people, this basic process breaks down in ways that reveal just how delicate the balance between waking and sleeping truly is. Insomnia, the inability to fall asleep or stay asleep, is the most common sleep disorder, affecting roughly 1 in 3 adults at some point in their lives. From the outside, it seems simple. Just close your eyes and sleep. But anyone who has experienced true insomnia knows it is not that simple at all. You're exhausted. Your body desperately needs rest, and yet your mind will not quiet. Consciousness will not dissolve. The transition into sleep refuses to happen. In quantum terms, this is a collapse that cannot occur. The wave function of consciousness remains stubbornly definite, unable to enter the superposition state of sleep. The observer cannot stop observing. In TCM terms, the Shen will not return to the heart, perhaps because heart yin is deficient, perhaps because the liver is agitated, perhaps because unresolved emotions keep the spirit restless and external. Chronic insomnia changes the brain measurably. The arousal centers become hyperactive, locked in a state of vigilance even when no threat exists. The person feels wired and tired simultaneously, exhausted but unable to rest, consciousness unable to relinquish its grip on waking reality. Treatment requires retraining the brain to trust sleep again, often through cognitive behavioral therapy that addresses the anxious thoughts that keep the mind spinning. Narcolepsy represents the opposite problem. Here, the boundary between sleep and wake collapses unexpectedly. People with narcolepsy fall asleep without warning, consciousness vanishing in seconds even during activities like driving or eating. REM sleep intrudes into waking, causing cataplexy, where strong emotions trigger sudden muscle paralysis identical to REM atonia. The dreaming brain leaks into waking reality. The separation between states breaks down. Narcolepsy is caused by loss of neurons that produce hypocretin, a neurotransmitter that stabilizes wakefulness. Without hypocretin, the brain cannot maintain coherent consciousness. The observer flickers on and off unpredictably. Classical reality keeps dissolving into quantum possibility without warning. Sleep apnea disrupts sleep through a different mechanism, repeated interruptions in breathing that jolt the person partially awake dozens or even hundreds of times per night. The person never reaches deep sleep, never achieves the sustained unconsciousness necessary for glymphatic cleaning, for memory consolidation, for restoration. They sleep for 8 hours but wake feeling as if they never slept at all. The brain tries to descend into restorative stages but keeps getting yanked back to lighter sleep, consciousness never fully releasing. And then there is fatal familial insomnia, perhaps the most terrifying sleep disorder of all. We mentioned it earlier, the genetic condition where the brain progressively loses the ability to sleep. Patients watch themselves decline over months, fully aware that sleeplessness is killing them, unable to do anything to stop it. No medication works. The brain has forgotten how to enter sleep states. Consciousness remains locked in waking mode until the system collapses entirely. What makes fatal familial insomnia so horrifying is what it reveals. Sleep is not optional. It is not a luxury, not a habit, not something you can train yourself to live without. Sleep is as necessary as oxygen. The brain must dissolve consciousness regularly, must enter restorative states, must perform the cleaning and consolidation that can only happen during sleep. Without it, the brain accumulates damage faster than it can be repaired, and death becomes inevitable. Each sleep disorder represents a different failure mode of the consciousness system. Insomnia, the observer cannot stop observing. Narcolepsy, the observer cannot maintain observation. Sleep apnea, observation keeps being interrupted, preventing depth. Fatal familial insomnia, observation becomes permanent until the system burns out. Treatment, whether through modern medicine or traditional approaches, aims to restore the natural rhythm, the balance between yang and yin, between waking and sleeping, between observation and dissolution. Sometimes medication helps rebalance neurotransmitters. Sometimes cognitive therapy addresses the thoughts that prevent sleep. Sometimes herbal formulas nourish deficient yin or calm excessive yang. Sometimes fixing the breathing problem with a CPAP machine allows deep sleep to return, but all treatments recognize the same truth. Consciousness must be allowed to dissolve. The observer must learn to let go. Sleep cannot be forced, but the conditions for sleep can be created, and when those conditions are right, when the brain is ready, consciousness will do what it has done every night for millions of years: fade, dissolve, transform into something else entirely. As we move toward the biological rhythms that govern when sleep happens, toward the circadian clock that times this nightly dissolution, let these disorders remind us of something precious. The ability to sleep is a gift, fragile and essential, worthy of protection and care. Chapter 9. The Circadian Clock, Your Body's Quantum Rhythm. Deep in your brain, just above where your optic nerves cross, sits a tiny cluster of about 20,000 neurons called the suprachiasmatic nucleus. These neurons do something remarkable. They keep time, not metaphorically, literally. They oscillate with a rhythm so precise that even when removed from your body and placed in a laboratory dish, they continue to pulse on and off in a cycle that lasts almost exactly 24 hours. This is your circadian clock, your body's master timekeeper, the conductor coordinating the symphony of biological processes that must happen at the right time of day to keep you alive. And here is what is extraordinary. Nearly every cell in your body has its own clock, its own oscillating rhythm. Your liver cells know what time it is. Your skin cells know. Your heart, your lungs, your muscles, all of them running their own internal clocks, all synchronized by the master clock in your brain. How does a cell know what time it is? Through something called clock genes, segments of DNA that turn on and off in rhythmic cycles, producing proteins that accumulate during the day and break down at night, creating feedback loops that oscillate with remarkable precision. The most famous of these is the period gene, discovered in fruit flies in the 1970s. Mutate this gene, and the fly's entire sense of time goes haywire. Sleep comes too early, too late, or not at all. Time, at the cellular level, is written into genetics. This is why jet lag feels so disorienting. You've travelled across time zones faster than your cells can adjust. Your master clock is trying to reset based on the new light-dark cycle. But your liver is still running on Tokyo time while your skin cells think you're in London and your muscles are confused somewhere over the Pacific. Your body is literally out of sync with itself, each organ operating on a different schedule until everything gradually realigns over several days. Traditional Chinese medicine described this circadian rhythm thousands of years before molecular biology discovered clock genes. The organ clock we mentioned earlier, the system mapping 2-hour windows to specific organ activity, is a circadian framework. Between 11 p.m. and 1 a.m., the gallbladder is active. Between 1 and 3 a.m., the liver. Between 3 and 5 a.m., the lungs. And on through the day, each organ having its peak time for energetic function. Modern chronobiology, the science of biological rhythms, has validated much of this traditional mapping. Liver enzymes do peak in activity during early morning hours, processing toxins most efficiently then. Cortisol surges around 3 to 4 a.m., preparing the body for waking. Melatonin production begins as darkness falls, typically around 9 p.m., signalling the approach of sleep. Body temperature drops to its lowest point around 4 to 5 a.m., then begins rising toward waking. These are not random fluctuations. They're orchestrated, coordinated, timed with precision that rivals atomic clocks. Your body knows when to release growth hormone. During deep sleep in the first half of the night, it knows when to suppress immune function slightly during the day so inflammation does not interfere with activity, and when to ramp it up at night when you can afford the energy cost of fighting infections. It knows when to make you hungry, when to make you alert, when to make you drowsy. And the master synchronizer, the signal that keeps all these clocks aligned, is light. Light entering your eyes travels directly to the suprachiasmatic nucleus, resetting the clock each morning. This is why morning sunlight is so powerful for sleep regulation. It tells your brain definitively, this is daytime, this is when you should be awake, adjust all downstream processes accordingly. Artificial light has thrown this system into chaos. For millions of years, humans experience bright light during the day and near total darkness at night. Now we flood our environments with light at all hours. We stare at screens emitting blue wavelengths that mimic midday sun. We work night shifts, forcing consciousness to remain active when every cell in the body expects sleep. We travel across time zones in hours instead of the weeks or months it would have taken our ancestors. The circadian system tries to adapt, but it is slow. It evolved for a world where light meant sun and darkness meant night, where the rhythm of day and night was absolutely reliable. Now it must navigate a world of constant light, irregular schedules, alarm clocks forcing waking at arbitrary times disconnected from natural rhythms, and here is where the quantum parallel emerges once again. The circadian clock operates through oscillation, cycles of genes turning on and off, proteins building up and breaking down, creating waves of activity that pulse through time. In quantum mechanics, everything is oscillation. Particles are waves. Energy exists in quanta, discrete packets vibrating at specific frequencies. Time itself, in some interpretations, emerges from quantum oscillations at the Planck scale. Your body's sense of time arises from molecular oscillations. The universe's flow of time might arise from quantum oscillations. Different scales, different mechanisms, but the same fundamental principle. Rhythm, pulse, the wave-like nature of existence moving through cycles. Traditional Chinese medicine speaks of this as the dance between yin and yang, not static opposites, but dynamic forces that rise and fall in rhythmic alternation. Noon is maximum yang, midnight is maximum yin. Dawn and dusk are transition points, balance points, where the energy shifts from one pole toward the other. The body follows this cosmic rhythm because the body is part of the cosmos, not separate from it. Modern science describes the same pattern in different terms: the circadian oscillation of gene expression, the 24-hour cycle of hormone release, the rhythmic firing of neurons in the suprachiasmatic nucleus. But the insight is identical. You are a creature of rhythm, of cycles, of time made biological. When you honor these rhythms, sleeping in darkness, waking with light, eating at consistent times, moving your body during the day and resting it at night, you align with something ancient and powerful. The molecular clocks in your cells synchronize. The organs perform their functions at optimal times. Sleep comes more easily because your entire system is prepared for it, expecting it, already beginning the transition from yang to yin, from activity to rest. And as you feel that transition beginning now, as evening deepens and the pull towards sleep grows stronger, you are participating in a rhythm billions of years old. Cells learn to anticipate the sun's rising and setting long before brains existed, long before consciousness, long before anything we would recognize as sleep. And that ancient timing system still pulses in you, still coordinates your descent into unconsciousness each night, still knows, with precision you could never consciously achieve, exactly when to release melatonin, when to drop body temperature, when to open the glymphatic channels and begin the cleaning. Trust that rhythm. It is older than thought, more reliable than will. Let the circadian clock guide you now as we move toward the final preparation, toward the practices and conditions that help consciousness dissolve peacefully into the restorative darkness of sleep. Chapter 10. Preparing the body for sleep. Sleep, as we have seen, is not something you do. It is something you allow. You cannot force consciousness to dissolve any more than you can force yourself to digest food faster or make your heart beat slower through sheer willpower. Sleep is autonomic, governed by systems deeper and older than conscious control. But you can create conditions. You can prepare the body and mind to enter the state where sleep becomes possible, even inevitable. Traditional Chinese medicine calls this inviting the Shen to return to the heart. You cannot command the spirit to come home, but you can make the home welcoming, safe, peaceful, a place the Shen wants to return to. Modern sleep science calls it sleep hygiene, the constellation of practices and environmental conditions that support healthy sleep. Different languages for the same wisdom. Preparation matters. Light is perhaps the most powerful signal you can give your brain. Remember, your circadian clock synchronizes primarily through light exposure. In the morning, seek bright light, ideally sunlight, but even artificial light helps. This resets your master clock, telling your suprachiasmatic nucleus that day has begun, that cortisol should rise, that melatonin production should cease. 10 to 15 minutes of morning light can shift your entire rhythm toward better sleep at night. As evening approaches, do the opposite. Dim your lights. In the ancestral environment, sunset meant firelight at most. Warm, dim, orange-red wavelengths that do not suppress melatonin. Modern LED bulbs and screens emit blue-white light that mimics midday sun, tricking your brain into thinking it is still afternoon. Your pineal gland delays melatonin release. your circadian clock shifts later. Sleep becomes more difficult. If you must use screens in the evening, enable night mode, which filters blue wavelengths. Better still, put the screens away entirely an hour or two before bed. Read a physical book under warm lamplight. Have a conversation. Sit quietly. Let your brain begin the transition from yang activity to yin rest, without the constant stimulation that keeps consciousness engaged and external. Temperature plays a crucial role as well. Your body temperature naturally drops as you prepare for sleep, a signal that the circadian rhythm is shifting toward night. You can support this process by keeping your bedroom cool, ideally around 65 to 68 degrees Fahrenheit. A warm bath or shower 90 minutes before bed helps paradoxically. The heat draws blood to your skin, and when you step out, your core temperature drops more rapidly, mimicking and enhancing the natural pre-sleep temperature decline. Traditional Chinese medicine recommends warm foot soaks in the evening, sometimes with herbs like mugwort or ginger added to the water. The principle is the same, drawing warmth and energy downward and outward, helping yang descend and yin rise, preparing the body for the inward journey of sleep. Modern physiology would add that warming the extremities dilates blood vessels, lowering core temperature, signaling the hypothalamus that conditions are right for sleep. Food timing matters more than most people realize. Eating a large meal close to bedtime diverts blood flow and energy to digestion when your body wants to be entering rest mode. Your liver and stomach must work when they should be slowing down. TCM recommends eating your largest meal at midday, when digestive fire is strongest, and keeping evening meals light and easily digestible. Modern research supports this. Late meals disrupt circadian rhythms, delay melatonin release, and fragment sleep with digestive discomfort. Certain foods and herbs have been used for centuries to promote sleep, and modern research has begun validating their mechanisms. Chamomile contains apigenin, which binds to benzodiazepine receptors in the brain, promoting relaxation. Magnesium, found in leafy greens and nuts, calms the nervous system and supports GABA function. Tryptophan, an amino acid in turkey and dairy, is a precursor to both serotonin and melatonin. In TCM, jujube dates and longan fruit nourish heart blood and calm the shen. Valerian root and passion flower sedate excessive yang energy. But beyond specific substances, the practice of preparing food or tea mindfully, of creating an evening ritual, signals to your brain that the transition towards sleep is beginning. Ritual creates structure. The body learns, when I do this sequence of actions, sleep follows. The nervous system begins to relax in anticipation. Movement during the day supports sleep at night, but timing matters. Vigorous exercise raises cortisol, increases body temperature, activates the sympathetic nervous system. All wonderful during the day, all disruptive if done too close to bedtime. Morning or afternoon exercise promotes deeper sleep that night. Evening exercise, especially within 2 to 3 hours of bed, can delay sleep onset. Gentle practices, yin yoga, stretching, walking, tai chi, are fine in the evening. They release physical tension without overactivating the system. Your bedroom environment itself deserves attention. Darkness is essential. Even small amounts of light can suppress melatonin. Blackout curtains, eye masks if needed. Silence helps most people, though some prefer white noise or gentle nature sounds to mask sudden noises that might cause arousal. Your bed should be associated with sleep and intimacy only, not with work, not with screens, not with stress. When you lie down, your brain should recognize this is where consciousness dissolves, where the shen returns, where rest happens. And perhaps most importantly, you must address what happens in your mind as you lie down. For many people, the moment the external stimulation stops, Internal noise amplifies. Worries surface, tomorrow's tasks clamour for attention. Unresolved emotions churn. The mind races precisely when it should quiet. Traditional practices offer gentle interventions. Journaling before bed externalizes thoughts, giving them a place to rest outside your mind. Writing down tomorrow's tasks and concerns tells your brain, these are handled, you need not remember them now. Meditation or breathing practices calm the nervous system directly. Slow, deep breaths activate the parasympathetic response, signaling safety and rest. Progressive muscle relaxation releases physical tension that often holds emotional tension. TCM speaks of calming the Shen through these practices, creating internal quietness where the spirit can settle. Neuroscience would describe it as reducing default mode network activity, quieting the amygdala, shifting from sympathetic to parasympathetic dominance. The mechanisms differ, but the experience is the same. The mind gradually releases its grip on waking consciousness. Thoughts slow and blur. The boundary between waking and sleeping grows permeable. And here is the final wisdom both traditions share. You must surrender. You cannot control sleep. You can only create conditions and then let go. Trust that your glymphatic system knows when to activate. Trust that your circadian clock has been tracking time since before you were born. Trust that your Shen knows the way home to the heart. Trust that consciousness, which has dissolved into sleep billions of times over the course of your life, will do so again tonight. The preparation is not about forcing sleep. It is about removing obstacles, about honouring the natural rhythms, about creating safety and darkness and stillness where sleep can emerge on its own. Sleep is always there, waiting beneath the surface of waking consciousness. You need only stop swimming against it, stop trying to stay afloat, and let yourself sink gently into the depths. The Shen is finding its way home. The glymphatic channels are beginning to widen. The quantum observer is preparing to dissolve. Everything is as it should be. Everything is ready. All that remains is the letting go. This is sleep entangled, where the deepest questions about consciousness dissolve into gentle answers, where ancient wisdom and quantum physics recognize each other as old friends, where understanding sleep helps you surrender to it. Tonight, as you lie down, remember, your brain knows what to do. The glymphatic system is ready. The Shen is finding its way home. The observer is preparing to let go. Good night.